Hi, this is Ruben, and I am your machine vision and image processing expert. Today's topic is selecting camera link cables. It can be very confusing selecting camera link cables, and hopefully this video and tutorial will help you in that process. So what we need, we'll cut to the chase so that if you just want to provide us with some information and we can provide you with a quote, this is what we need. We need to know the pixel clock speed, the connector type, if it's HDR, SDR, or MDR, and what end, is it the camera end, the frame grabber end. We need to know the length, and we need to know the mode. Is it base, medium, full, deca tap, 10 tap, 8-bit mode? Does it need anything else besides a straight exit? Meaning, does it need to go up 90 degrees or down 90 degrees? If you can provide that information to us, we most likely will be able to provide you with pricing information. If you want to learn more about this, then stick with this presentation here, because I'm going to talk in detail about this. So in the beginning, cameras used to communicate with frame grabbers, and generally the cabling between the two was a nightmare. The standards were RS485, LVDS, RS422. Each camera manufacturer made their own connectors and their own cables. Each frame grabber company made their own connectors and their own cables. It wasn't unusual to spend several $1,000s for a cable, even $5,000 for a single cable to communicate between a digital camera and a frame grabber. So out of the chaos in the year 2000, the Automated Imaging Association, or the AIA as it's called today, created the camera link standard. And the camera link standard was basically to make connections between cameras and frame grabber standard, to make the standard a real-time standard for machine vision, and make the communication fast and robust. There are several different modes for camera link. There's base, which is 2.04 gigabits, medium, which is 4.08 gigabits, which is twice, and then full, which is 5.44 gigabits. Of course, there's the Deca 10 tap 80-bit mode. The scope of this presentation is not to discuss the camera link standard. It's just basically to talk about how to select a cable for a camera link camera. If you want to learn more about the camera link standard, I've provided you with a link, which is the Automated Imaging, or AIA link, that provides details about the standard. So please, if you want to learn more about it, go to this link. Cable length. AIA standard is 10 meters. However, the length of the cable is more related to the pixel clock speed of the camera. On this table here, you can see that an 80 megahertz pixel clock is going to allow you about a 9-meter cable. 33 megahertz pixel clock is going to allow you about 15 meters. For those of you who have 85 megahertz cameras, which are now very common, you're looking at a 7-meter cable. So it really depends on the pixel clock. The type of connectors that are typically used for camera link are the MDR26. It's a 26-pin connector. There's a male connector and a female connector. The male typically runs on the cable. The female typically runs on the camera and frame grabber. Here's the measurements for the MDR26. If you're not sure what kind of connector you have, just take out a little measurement device, micrometer, and measure what your cable size is. Here's a picture of an MDR male, which is typically what's included in the cables, and the MDR female which is typically done on the cameras and frame grabber side. Now, why would you want to buy a female MDR connector cable? Is because you might need a patch cord that goes into an enclosure. So you might buy a short male on one end, female on the other end. But always keep in mind that the camera and frame grabbers always use female, and the cable side is always male. Another development was the HDR SDR standard. The reason this was developed was because cameras were getting smaller, frame grabbers were using less of a footprint on the computers, and so in order to accommodate the smaller cameras, Honda came out with this smaller camera. It's a 26-pin connector, and then that's what the HDR is. The SDR is the 3M version of basically that same connector. If you think you have one of these, then use these measurements here to determine whether you have the HDR type of connector. The HDR is electrically compatible with the MDR26, so it is possible, in fact it's fairly common, to have maybe an MDR connector on one end of the cable and an HDR connection on the other end. Connector information. Our connectors are formed, molded connectors. They have copper tape around the connector to provide extra isolation. In general, molded connectors are more robust. That certainly applies to camera link connectors. Ours are molded. There's less mechanical failure that can occur, so they tend to be very good, very long-lasting connectors. Another development that came out of the AIA was running power through the camera link cable. All camera link cameras have to be powered from some power source, and typically you run a DC line into the camera. The AIA decided to create a new standard that allows power over camera link cable. That's where the nomenclature POCL, power over camera link, came from. It takes the pins 1 and 26 of the standard camera link cable and redefines them from shielding to power. The power is 333 milliamps on 12 volts DC, or 400 milliamps at 10 volts DC. The power over camera link cables are backwards compatible with non-power camera link cables. So if you have a non-power camera link camera, you can use a POCL cable on it. But if you have a power over camera link camera, you really need to use the POCL cable. So selecting the cables, this is basically a cut-off view of what the installation looks like. The real key factor here is that type 1 and 2 uses 28 gauge wire. That means that it is a little bit better at communicating the signal. There does exist a type 1, a type 2 for power over camera link. There's also the AWG30, which is a 30 gauge. It's a little thinner wire. There is a power over camera link 30 gauge wire. The difference is going to be about 20% length. So if you need the extra length, then the 28 gauge is probably the way to go. As far as the exit, there are various types of exits to use. You can have straight. Incidentally, most cables that are ordered, camera link cables, are straight. But if you need a right angle, pointing down, pointing up, left, right, or if you need one that's 135 degrees pointing to the right, to the left, whatever, we can accommodate you. Just let us know if you have space limitations that's going to require you to use a different type of exit. All of the cables are 100% tested to meet performance standards at 40 megahertz, 66 megahertz, and 88 megahertz. That's unique in the industry to test 100% of the cables. So the question comes up, what if I want to go longer than, say, 15 meters in base mode? Is there a solution? And there is. The Bitmax cabling from CI is an option. So what is Bitmax? Bitmax is an active cable. It uses channel link technology to determine the preemphasis and the equalization. There are two versions of the Bitmax. There's the EP and the higher performance P. Higher performance meaning it gives you a little bit longer cable, but both of them are basically the same technology of using channel link technology. Here's a drawing of how you would specify a Bitmax cable. You need to specify the distance from the electronics to the camera side. Here it says XX meters, and then you also need to provide the distance in meters from the electronics to the frame grabber side. As I mentioned, it is active, so it does require a power supply. So you plug it in on the frame grabber side, and that's how it works. You also need to know whether it's an MDR or an HDR connection. Here's a chart that basically tells you what the added length capabilities are. Just to give you an idea, if you're at maybe 45 megahertz, you could go all the way out to about 22 meters in base mode. If you were at 35 megahertz in full, you could go out to 21 meters. So this gives you an idea of what the EP version can do. And of course, the P version can go a little farther. Here is a drawing of a 25 meter base Bitmax P cable. And here's one that's in full version. That's 15 meters. So if you need a greater length than what is typical for a standard camera link cable, the Bitmax does offer you an option. There are also some other options with fiber optics, which I'm not going to address in this particular presentation, but fiber optics is an option. It tends to be a lot more expensive, but it is an option. Selecting camera link cables, what information do we need from you in order to provide pricing? As I mentioned, give us the pixel clock of your camera. Let us know what type of connector it is. Is it an HDR, SDR, or an MDR? HDR and SDR are the same. And what ends, sometimes you can have one MDR and one HDR on the same cable. We need to know the length, and we need to know what mode your camera is. Base, medium, full, Deca 10 tap, 80-bit mode. That's all I have regarding selecting camera link cables. I hope this tutorial was helpful. Please contact us if you have questions or if you would like pricing. And here is our contact information. Thank you very much.